Hello, I am Ryan Lynn, and this is Collecting Underpants to Own Your Network. So we're going to start off by talking a little bit about, I guess, why we're here and how the project that I've created will help everyone. And I really don't like PowerPoint slides very much. I don't like making them, and I don't really like looking at them. So we're going to talk. We're going to look at demos for most of this. And then after we see what we're actually dealing with as far as the passive information gathering stuff, we're going to look at how the backend works. So we're going to look at demos first. Then we're going to look at code. So if people don't like code, then when I start showing code, you can, go and find something else that you find more interesting. And then we're going to talk a little bit about the protocols that are covered and also how to help develop plugins, and then also remediation for some of the things we talk about today. So that's me. You can read the stuff. And I've done a little bit of stuff with Metasploit project, developed a little bit of code with them. Also, one of the contributors to Beef and a couple of the other open source projects that are listed. We're going to see today Metasploit and d3t and some of the integration there. So I want to start off by talking about sort of what we're dealing with, and that's passive information gathering. And where this came about was while doing pen tests, one of the first things that we did when we logged on the network was looked at TCP dump just to see what's talking. So you see a lot of different things. You see CDP traffic a lot of the time where you have advertisements from routers and switches saying what their configuration looks like. You see SMB broadcasts to see what other hosts are on the network. And Wireshark is awesome. You can dig in and look at all this stuff, but it's not really practical if you just want a list of the stuff that you've actually got. So what I wanted to do was create an easy way to inventory this. And since I was already using Metasploit for a lot of things, and Metasploit's an easy framework to develop with, I thought, well, Metasploit's already got an awesome database that can store all of this information. So why not look at the broadcast traffic on the network and categorize hosts, gather as much information I can before I start doing any sort of scanning or other sort of recon, and just store that, see how much information I can find. So what I did is I developed a plugin that would allow me to easily do that. And one of the things I wanted to make sure that I could do when I did that is make it as extensible as possible. A lot of the pieces of Metasploit are very compartmentalized so that everything is in a nice little bundle, but I wanted to have something that was a little bit more extensible. So what I did is I created a module that had a set of plugins that you could load for each different type of protocol. So obviously I don't see everything that everybody else sees. So I wanted a way to make it easy for somebody who found another type of protocol that they wanted to parse to be able to add that. So what we want to do is we want to be able to identify hosts and resources on a network and profile all of the different pieces, whether it be the types of hosts through multicast DNS or SMB hosts. We want to gather as much information as possible. But we also want to be completely silent. One of the nice things about this is if you land on a network, before you start just sending stuff out that's going to trip IDSs, host firewalls, those sort of things, you can just listen and gather quite a bit of information and know what your targets are. A lot of the time also, honeypots aren't going to be broadcasting out. So if you're looking for actual hosts that are participating in the network in some sort of meaningful manner, this is also an interesting way to gather that information. So the other thing is a lot of the passive information gathering stuff that's already out there requires man in the middle. It wants to be on a span port. It wants to see the whole portion of the two-way communication, so I can do passive OS fingerprinting through P0F and that sort of stuff. And I didn't want to deal with that. I wanted to just be able to look at broadcast and multicast traffic. So this doesn't require any sort of special access to the network. It doesn't require anything but just basically being on the same network as other hosts. So going back to South Park, the general principle is first we want to collect underpants. And then we're going to talk about what fills in the question marks, but then we're going to get to profit or winning or whatever else the goal is. A lot of the time we talk in pen testing about winning or domain admin or whatever, but the end goal is we want to gather enough information to be able to complete our goal. So there's a lot of different people that I'd hope to target this for. One is for the sysadmins and average users. So if you've ever gone into Starbucks and participated in the network, or anywhere else where you basically log on to the network, you will see all sorts of things where broadcast traffic will be out there. So you want to see how much information you can see about the other people in your network. So one of the things is this will allow you to see what information you're sending out, and also for sysadmins who want to know what sort of information their servers are sending out just by participating in the network. This will help them. Also for pen testers, it really helps you profile. And for everyone, even for your home network, if you're interested in seeing what your iPhone does when it connects to other networks, this will be useful for you. So the nice part about this is it does make everything a little bit easier. We're going to talk about how to get the information in and out of the Metasploit database, as well as how to use the d3t framework, which is a reporting framework, in order to be able to look at the information a little bit better. But also this will talk a little bit about how to stay quiet on the network so that as we are moving forward, we're not basically sending lots of packets out. Everything's coming to us. So I'm going to start off with a couple of demos real quick. First one is going to be just loading a PCAP file in and looking at how to use the plugin and deal with the basic data. So first we're going to start Metasploit. And the module name that I've created is called PIG, for Passive Information Gathering. The backend framework has changed a little bit since I first wrote this, so I'm in the process of rewriting it. Metasploit was originally using the Racket framework, and it is now using the Packetfoo framework. And so I'm in the process of moving everything from Racket to Packetfoo. So this will work on MSF3, and it will not work on MSF4 yet, but that is coming. So we're going to use the auxiliary sniffer PIG module. And can people see this in the back? Awesome. So we're going to look at options real quick. And so we see a couple of different options. One of the interesting things about the Metasploit framework for the plugin that deals with sniffing is it has an R host. From what I can tell, it's not actually used. So I need to figure out how to get this out of this easily. But for right now, we can set R host to anything and it will work. So we're going to set it to localhost. And then we set our filter to packet capture. So, we set the PCAP file to the place we want the actual PCAP file to be loaded from. And so I have a couple here from DerbyCon, and one is broadcast. So basically, once we have all the options set in, we just type in run, and the protocols will limit what protocols are loaded and actually parsed. So we'll go through that in a minute, but for right now, we're just going to run all of them. So once we run it, we can see that there's a number of different types of packets that we're seeing. As it sees each individual type of packet, it'll print out a message. And so what we're looking at here is a lot of DHCP traffic where hosts are doing DHCP probes for addresses. So you'll see a couple of different types of addresses for the DHCP packet. Metasploit has a limitation where you can't create notes for hosts that don't have IP addresses. So one of the hacks that I've done is if a host for a DHCP request does not already have an IP address and you can't see the acknowledgement come back, we make one up based off the MAC address. And so we take the last 4 octets and generate a IP address based off that. So now we have everything loaded in. And let me see if I actually have the database connected. I did not, so let's go back and do that. So let's go ahead and destroy the old database we had. And recreate the database and run this again. So basically I'm using Postgres on the back end, which older versions of Metasploit supported SQLite 3. Now MySQL and Postgres are the only two supported. So There's easy tutorial for how to set up the Postgres in Backtrack and other places. I'm right now just using base Ubuntu, but all of this works under Backtrack 5 as well. So once these are all loaded, we have the ability to go back and look at our hosts. And so we can see that these are the individual hosts that we found. So we can also look at services that were there. So let's load one more file. And so this one has CDP and the Simple Service Discovery Protocol, which is network plug and play. And so we can see that there are now new hosts and services. So for the protocols that we detect, we add hosts and services entries in for each one, so that this information can also be used as part of AutoPwn or anything else that you're looking at targeting. But it'll also map easily into d3t. So most of the information that is interesting is under notes. So this is kind of hard to look at. But the interesting things are, for instance, this one right here, we can look at the different note types. So for this one, this is a passive SMB note, and it has information about the host that was broadcasting. So we know the OS version. We know that it is advertising both workstation and server services. It's also a potential browser. And one of the interesting things that we get from this is the domain. So if we're looking at easily figuring out what domains we're dealing with, just looking at this will show you how many domains you have on the local network. So you don't have to do any sort of special recon. You can just let all that come to you. The other interesting one is we find a lot of vulnerabilities with SQL servers on workstation domains that have blank SA passwords or SASA username password. Microsoft is awesome because they'll go ahead and tell you that it's running SQL server, so you don't actually have to nmap anything. It'll just tell you. So you can just sit and listen to all of the hosts that are advertising for SQL server and get those out very quickly. So the other one that is interesting is CDP. So a lot of the time you will see CDP enabled on networks, and it makes everything really handy because you get all sorts of great stuff, like what type of hardware it is, what the actual VLANs are. So a lot of the time you'll see both the native VLAN, you also see information about the voice VLAN. So if you're dealing with voice traffic, it'll show that. But most important, it'll show management addresses. So if you're looking at doing any sort of modifications to the switch, it'll tell you exactly where you need to send your SNMP queries. So from here, like I said, this is sort of a pain to deal with. So one of the things I wanted to do was let another program deal with this a little bit easier. So we're going to look at d3t real quick. And d3t is a pen test reporting framework. And what it is designed to do is create nice little nodes where we can easily organize the information. So I'm going to go ahead and reset this so that all of the files are backed up when we start over fresh. And we will restart d3t. And d3t is going to listen to localhost port 3004 over HTTPS. So let's connect there real quick. So my awesome username and password is admin because it works so well in the real world. And so now we can see here that we have just a basic reporting console. So the next thing I want to do is I want to go back into Metasploit, and we're going to use XML RPC to transfer the data between the two. So for here, we're going to do load XML RPC, and we're going to use the secure password test. So basically, the XML RPC daemon will bind itself to localhost on port 55553. And it requires username and password. Default username is MSF, and our super secret password is test, so that we can import this. The super secret password test is also the default password that d3t uses, so for connecting. So if you want to actually change that, if you go under d3t and go into configuration, all of that is configurable here. So you can actually pull this off of remote Metasploit hosts. So if you're reporting on a different host than you're actually doing testing on, this makes it a little bit easier. So what we are going to do now is we are going to use d3t to actually import all of the data. So we do this from the server directory, and d3t uses Thor in order to deal with external commands. So what we want to do is Thor list and grep for MSF. So we can see here that the command to import the data is Thor d3t import msf.all. So we will go ahead and run this. And we have to wait a second for it to pull everything in. But when it's done, we see that it filters ran successfully and everything has been imported. So we come back over here, get out of that. And when we refresh our branch, we see that all of our Metasploit hosts that we looked at are in here. So now if we want to look at the information that we've already captured, we can just expand all. And so for each host, you can see the information that we gathered. So for instance, for DHCP, we can look at all of the DHCP information for here. So where this is going to be interesting in the future is I'm working on creating some fingerprinting for this. There's already some stuff out there, but be able to do actual OS version fingerprinting with this so that you can get version information on Windows hosts without actually having to do any sort of scanning on them. The order that they request DHCP information in is important. So all of that is going to be in here, and this will allow us to passively identify hosts. So we can see from here that all of the information that we had before is listed. So also we can see that for the ports that we had for the passive SSDP, which is the network plug and play, we can look at this and we can already see that this is a Windows NT 5.1, which is Windows XP, and we have the URL that we can go to find out more. So where this is interesting is a lot of organizations have security cameras. And I guess the physical security team doesn't ever really talk to the InfoSec guys before they start deploying cameras. So this is awesome if you just want to like do some actual video recon of your target. Because a lot of the time you'll see the cameras come out. You can look at this and it'll go ahead and tell you exactly what type of camera it is. You connect to this location and it'll tell you what the admin server is to view the camera. So the next step from there is a lot of the time, the network plug and play is extremely helpful. So occasionally it will also give you the username and password. That's the default. So then you can go ahead and look at the camera. So we see this every now and again where the cameras for the building are on network plug and play. And so that one is frequently interesting. But also for the CDP, this is very helpful. So we can see again for the SMB browser, all of that information. And so all of this is organized. This is just a few hosts to make it a little bit easier to deal with. As the hosts get more and more, this takes a longer and longer process. So let's come back here. So the next thing I wanted to talk about is Meterpreter in Pig. So unfortunately right now, Meterpreter's sniffer plugin is broken in Metasploit. It has been for about 2 months. But basically there is an additional script that we can run that will allow us to capture all of this information through a Meterpreter session. And so let's look at that for just a second. Sorry. And so I have a handy dandy Windows box close by, which I have secured by turning off the Windows firewall. It's passkey, what can you do? So let me get the IP address from that real quick. So we'll set our payload to handname interpreter. So we'll go ahead and exploit that. So we go ahead and we get our session. So then we have basically a pig recorder. And so from here, we have the ability to capture broadcast and multicast traffic. So I've gone ahead and done this to see what we can see. Like I said, this isn't going to work right now because this functionality is broken. But so basically all that you have to do is run pig recorder and choose an interface, which is usually 0, and then hit enter. And this will start capturing packets and putting them in your home directory's .msf4 directory under scripts and logs that will capture the packets until you stop it. So once that happens, we can go back into the pig module, and we can set another PCAP file. So we'll do this one. Same options, and run. And so here we can see that we see a lot of other different types of packets. You'll see things like MDNS a lot, which MDNS, for folks that don't know, is Apple's discovery protocol, used a lot in iTunes, iPhones, a lot of other devices. It's extremely helpful. So you can see that there's all sorts of new IP addresses here. So we can see now from these hosts that we can actually see a lot more information. So now we know who's on our network, what types of devices just from the host names, but also from the services, we can find out a lot more information. You can see here that some people may not actually turn the multicast DNS off, so you may want to do that. That was sort of a surprise to me. So that's now one of the first things that I go back and do. And so you'll see that there's a lot of Windows hosts here, the 138 UDP, and we can see from the DB services or the DB notes that we have a whole lot more information about the different types of computers going on here. You still see the hosts that are part of the workgroup domain, and you'll see different types of DNS. So if we want to filter this a little bit, a lot of the time we don't care about all of this. So let's do a DB notes for MDNS. So we can see from here that for the mdns.txt, we see 2 different entries, but we can get a whole lot of information for this. So this one is especially interesting. MDNS typically gives out a whole bunch of information about the types of devices that you're dealing with. So here we've got an awesome PhotoSmart C4700 series printer. We can administrate it from this address, and we can see all sorts of other interesting things like it is color, it's not duplex, and it can't staple. So if you're looking for like high-powered multifunction printers to do interesting things like we're talking about in Dennis's talk, this is one way that you can easily identify those on a network. You can look for the MDNS traffic and look to see what's broadcasting and see what sort of features are available. So now that we've looked at a little bit how to deal with it, I wanted to talk a little bit about the backend architecture. So let me get out of this. The main stuff for Pig is in the auxiliary module, but all of the plugins are under data exploits Pig. And so these are the different protocols that we parse right now. We do CDP, DHCP, Dropbox, Groove. You can read. So the nice part about this is I wanted to make sure that we did not process every single packet that came in. We only processed packets that were interesting. So for interesting, let's look at for example, let's look at CDP real quick. So there's a register rules function for each one. And so with register rules, what it does is it sets rule sets for when the packet should match to be processed. So for this, it will only process packets that have this destination MAC address. So this will let you deal with things that aren't specifically TCP UDP related. So you can deal with it just based off the MAC address. So this is multicast, and that is the MAC address that all of these are sent to. So from there, there's a parse adder, there is a parse function that handles all of the different actual pieces. So from here, you actually break apart the packet and get the different pieces of information. And then the final piece is to actually report it. So the report note function will both report the actual node itself, but also if you have a service or IP address that it's bound to, the report note will go ahead and create the service for you at the same time if it's bound to a service. And you can see something like that here with Groove. So you can see here that for Groove, we have a port and its UDP, and so we can look at all of that together. So now that we've talked about that for a second, let's talk about the different types of protocols that we actually deal with. So we already talked about that. So for CDP, one of the nice part about CDP is it gives you lots of information about OS version and IP address information, as well as VoIP VLAN. So CDP is awesome. It'll give you information about where you need to VoIP hop, where you need to be sending SNMP queries, all of that type of information. So a lot of the times we'll recommend people turn off CDP for areas that don't require CDP, just because it does give away so much information. Also, if hosts are using CDP, you can sometimes actually use that to your benefit. For instance, VoIP devices, a lot of the time will use CDP to help identify what is a VoIP phone. So you can actually craft CDP packets to participate in the VoIP VLAN. So DHCP, it's not completed yet, but right now we're pulling out MAC addresses, host names, and vendor classes. The vendor classes are what allow us to actually do, the vendor classes and request lists are what allow us to do fingerprinting. The order that those appear in is different across operating systems and across operating system versions. So there's some information out there already. I just need to compile it in and get it working so that as you see hosts come in, you can identify different versions of OS X and Windows based off that information. So Dropbox is kind of fun. Everybody knows about all the different Dropbox vulnerabilities that have come out. But the nice part about Dropbox is it screams on the network that you're running Dropbox. But it also tells you what namespaces it's using. So where that's handy is if you have two people who are using the same namespace, you want to get access to it, you can pick the one that's more vulnerable in order to get access to it. So you can find people who are communicating together with Dropbox and group them accordingly. So it also shares Dropbox version. So if you know that a certain version of Dropbox is vulnerable to something along the lines of, you copy the home directory from one box to another and you have access to all the stuff, then this will tell you which version you're using. Groove is especially nice. Groove is part of the Microsoft Office suite, and it will actually tell you quite a bit about what's going on the computer. So it'll tell you whether or not it itself is online or offline. It'll give you port information, but it'll also give you all the addresses on the system. So if you're running VMware or any other kind of virtualization software on the box, it'll list you all of those IP addresses. It'll also help you target hosts that have VPNs set up. So for instance, if you're on a network looking for PCI data, you know that the hosts are VPNing into the PCI network. If they're running Groove, you can easily tell which ones are actually actively VPN'd in. So you can really limit the area that you're targeting to only those hosts. It'll also tell you Groove version, so that if you're interested in doing specific Microsoft Office exploits, you can tell what version of Office that they're running in order to target those more specifically. MDNS is my favorite. It will list open ports on systems. It will also list IP addresses. There is a status MDNS message that the default chat client for Mac will send out to let you know whether or not somebody's actively at their keyboard. It will also give additional functionality. So if you want to, again, find the printer with the stapler, you can easily do that. But basically for a lot of devices, it's a free port scan because, for instance, the information that I was showing about my Mac earlier showed that I had SSH open and then I had something else open. So it'll easily let you identify those types of hosts. It also lets you identify a lot of the time people's names because Apple iTunes sends out MDNS messages, so you can identify who owns the asset. So if you're interested in doing some social engineering, that information will come to you. SMB, we talked about that a little bit earlier, but it'll give you host OS version, whether or not it's a server or a client. The server basically just means that you have file sharing on. So if you're interested in looking at hosts that have potential shares, you can look at the server service. Client is everything pretty much. But it'll give you host name and domain name so you can easily map out the different domains that you're dealing with, as well as other interesting things like whether or not it's an SQL server. Also, you can tell information about whether or not it might be a domain controller or not from this. SSDP is the network plug and play. You can get all sorts of information from it. Again, cameras are very common, printers are very common. Other things are if you have, for instance, somebody who's got a rogue Linksys router out there doing something interesting with it, you'll frequently see those. You'll see other types of devices that are attached. Occasionally you'll see not just the network cameras, but you'll see people's cameras that are sitting at their desk. I've seen that quite a few times, so if you want to watch somebody work, you can easily get to those. Macs will also sometimes send out these, so that if you want to connect to your Mac, you can, connect through network plug and play. Those are always interesting. Sorry. So how do we fix this? For NetBIOS, what we want to do is, in most cases, NetBIOS does not actually need the NetBIOS over TCP. So we don't actually need to have that enabled. A lot of the time this is enabled as a legacy thing. Everything since Windows XP doesn't need it. So as long as you don't have something older than Windows XP on your network, DNS is pretty much good enough. For SSDP, the easiest way to deal with that is to disable the network plug and play on your system. Also, for devices as you deploy them, unless there's a special reason that you need network plug and play, go ahead and disable those. For DHCP, for CDP, CDP is sort of a pain. For Cisco devices, it's a global option, so you can either enable it globally or disable it globally. What I recommend in most cases is for edge switches and devices, you disable it, and if you really want it over the core to see where your core is talking, then that's a little bit more friendly, but surfacing it to edge nodes isn't usually necessary. There's lots of software out there to help you manage Cisco devices and show where each device is attached to. So CDP, I don't think is really as necessary anymore. DHCP helpers can limit where packets go. Most of the major switch and router types support DHCP helpers. And what they do is limit where these packets will be directed to. So instead of being flooded out for broadcast, they'll be directed just to a single host. For Dropbox, disable LAN sync. That will make it so that you won't find your friends on the local network and you'll have to go through Dropbox. So it may save you a little bit of bandwidth to have it on, but it won't tell everybody that you're running Dropbox. Groove is kind of funny because the only way I found to disable it is to uninstall it. If anybody knows of a good way to disable the Groove communication, I would certainly be interested in that. And for MDNS, disable it when possible. It may not always be an option. Obviously, if you're sharing iTunes with friends over the local network, you don't want to disable it because then you won't be able to see your friends. So just limiting it to as much as possible is the best option. So as far as things that people can do to help if you're interested, I'm interested in getting some more data always to see what other types of interesting traffic is out there. So if you have multicast or broadcast traffic that you're interested in sharing, it's pretty easy to create these filters. So I'd love to see more of that information. Finish the DHCP host identification and also more protocols. So the information from Meterpreter right now, everything is moving from the Meterpreter scripts and moving them to post modules. So I'm working on creating a post module that'll handle all of this and actually do the processing in the post module, as opposed to just capturing the data and then passing it back into the base parser. So that's coming. As soon as the sniffer stuff gets fixed, we're gonna go through and do that. Also for the protocols, obviously we want to collect as much data as we can and get as much other information as we can so that we can profit more and better OS. So that is where the code is right now. I will be updating it shortly, so it may be broken for a little bit. Try to get everything updated by tomorrow. So if you're interested in downloading, I would wait for tomorrow to get the latest stuff. I added a couple more things since the last release, but trying to give one place to keep it updated. Also, if you're interested in learning more generally about Metasploit and coding for Metasploit, you can go to metasploit.org. And also, we just had a book come out, Coding for Penetration Testers. I think all of the copies here right now are sold out. But if you're interested, Synchronous tells me that they may be offering a discount code in the next couple weeks. So you may want to check in the next 2 weeks or so and see what they have coming up. And other than that, thanks for listening. Does anybody have any questions? Yes. It depends, I guess, is the answer. A lot of the time they're not going to be sent out, but a lot of the time they are. So it really depends on the network configuration. It always depends on the network configuration for CDP. So for instance, the question was, can you see CDP packets on wireless? Yep. Can you see CDP packets on wireless was the question. And the answer is, it depends. So for instance, for like Aruba, you're not going to see any broadcast traffic on the wireless. For Cisco stuff, you may very well see CDP packets on the wireless, but it depends on what is being broadcast and what's out there. So it depends. Any other questions?
You played with Network Miner.
Beg pardon?
Network Miner.
I have not played with Network Miner.
It's a Windows tool for doing like OS detection. Use like the fingerprints from off and gear cap. I think it's a toy. It's another tool. Tries to grab like what the name of the box is. Give you some OS fingerprints. Unfortunately, not fingerprints. It's pulling from like older software that doesn't necessarily hasn't kept up to date, but it's pretty nifty.
I will check that out. Adrian was mentioning Network Miner for Windows. And one of the interesting things with POF is that really POF, it wants to see actual TCP communications as opposed to broadcast. So POF isn't as useful when you're just looking at broadcast and multicast traffic. But sort of the next step for this is as part of Pentest, we are doing more man-in-the-middle type activity. And so sort of the next iteration of this is going to have more types of things to look at for when you are man-in-the-middling. So we'll have more POF, but it'll also have some other gathering stuff for looking at, for instance, we still see POP traffic periodically. We still see IMAP traffic periodically. Looking at basic auth over web pages, grabbing those hashes and going ahead and adding those in, those sort of things. Metasploit has a loot table so that all of that can be stored easily and retrieved. I guess that can be easily dealt with. Somebody have any more questions? Cool. Well, thank you guys very much. If you have any other questions and didn't want to ask, feel free to come by and chat.